Hello there and welcome to video number 3 in our pseudocode series. This question's all about car windscreens, so let's jump straight in. A manufacturer produces car windscreens. The machines which produce the windows are not completely accurate and sometimes produce windscreens which are slightly too wide to fit in a particular car. You may assume that the windscreens produced are never under width, so we don't need to do a check for that, which is good. Tests are made on a sample of windscreens. In each case, the width of the windscreen is measured. All width are in millimeters. So that might be important, so let me underline that. Design an algorithm using pseudocode with the following inputs. So I've got 3 inputs again. The required width, the number of windscreens to be sampled, the width of each of the windscreens in the sample, and the outputs for the program should be for each windscreen found to be over the required width, the windscreen number, so that's 1, 2 or 3, etc., with the width of that windscreen. So the program should also output the total number of windscreens sampled, the number of windscreens in the sample which were of satisfactory width, and that in total gives us 3 outputs there. All outputs should contain suitable messages where helpful. For instance, if the inputs are, so that 1320 there, that is the required width of the windscreen, so it's 1320 millimeters. 7 is the number of windscreens that are being sampled, so we're sampling 7 windscreens, and then we are inputting windscreen 1, windscreen 2, windscreen 3, 4, 5, 6 and 7. Then we check each one and we say, if that is over that, then we need to output something. So here, when we run through this with our algorithm, over width windscreen in position 1, that's this one, and that is 1321, so it's 1 millimeter over that one. Over width windscreen, that one's acceptable, that one's acceptable. This one is too big by 2 millimeters, so that one also gets outputted. So position 4 outputs 1322, and that's checked, and then we move along. That's okay, and that's okay. So total number of windscreens tested is 7 in total, because we've got that from there. And then the number of satisfactory windscreens is 5. It's because 5 of them are good, 2 of them are bad. So now what we need to do is turn this into an algorithm. Let's start with our variables. So the first thing I'm going to do is I'm going to put in here rec width. So what is the required width? And that is going to be of type integer. So that's that one. Next thing to do is the number of windscreens to be sampled. So we'll call that sample, and that is also going to be of type integer. Thirdly, the width of each windscreen in the sample. Now what I'm going to do, the width of each windscreen, is I'm going to do that in a loop. And the reason why is because looking at this here, the sample is 7 and we need to enter 7 inputs. So I'm going to do that in a loop to save me writing lots of code, I think. The outputs, windscreen number, that gets outputted automatically. The total number of windscreens to be sampled, that's that one, we've already got that there. The number of windscreens which are satisfactory width. Okay, so I'll just call that sat width. So they're the ones that are satisfactory width. And that, again, that's an integer. If I need any more variables, as always, I will go back up to the top and add the variables in. What I need to do is I need to get these variables initialized by the user, and I can do that by using the word set again. So I can say set the required width to equal enter the required width. Then I will say set your sample to equal an input from the user, how many windscreens, and I think that's all I need to input at this time, because the next thing I'll do, I'll leave a bit of space there in case I need to initialize any more. The next thing I'll do is I will use a for loop, I think, because it's static. And I'll go with I for this. Again, you can call this whatever you like. I've just gone with I. And I'll give I the value of 1. So we're going to start at 1. And we're going to go up to the sample size. So think about a loop. Sample, in this example here, the sample's value is 7. So it's going to go 1, 2, 3, 4, 5, 6, and 7. And it's going to stop. So it's going to iterate 7 times in total. Now what do I want to do inside that loop every time? Well, I want to create a temporary variable and get the user to put in the windscreen. So what I'll do is I'll just make a temporary variable here. Temp is integer. Enter screen size for screen, comma, I. So that'll be enter the screen size for screen 1. Then I'll iterate screen 2, iterate screen 3, screen 4, screen 5, screen 6, screen 7, and stop there. Okay. Now I've got the actual input for the first one, which is 1321. I need to check if that is out of the width. So I can do that by saying if the thing that's just been entered is greater than my required width, which I entered before, what does that tell you? It tells you that that is an over width windscreen. And what we need to do is the windscreen needs to be outputted, so it'll say over width windscreen, the position, and then the actual value. So what I'll do is I'll put an output here. So over width windscreen and its position. Now how do I know its position? Well, I'm talking about, this is the first one that we're on here, and I is going to hold the position every time. So if I put I there, it will say over width windscreen 1, or if it was the 4th screen, it will say over width windscreen 4. That will hold the position. And then I also need the actual size. So if I just put a comma, space, because I want it to be spaced out a little bit, and the temp, I think. So temp is actually my windscreen's value, and I'll close that up. So I'll say over width windscreen, position 1, and then the actual value of that windscreen. So that's that one done. Done that. Done that. I've done that. Absolutely flying here. So okay, that's fine. I do that every time. Now we need to know the number of windscreens in the sample which were of satisfactory width. So here, what I'm going to do is, if it's over width, then it's going to output over width. Else, I'm going to say satisfactory. So I'm going to need another variable, I think. Satisfactory is integer. And I'll say else satisfactory equals satisfactory plus 1. So every time we've got something that's over width, output that. But if it's not over width, that means it must be the correct width, because remember, you may assume that the windscreens produced are never under width. Okay, done that. Total number of windscreens sampled, well, that's going to be my sample. The number of windscreens in the sample, which has done that one, yeah. Okay, I think we're good. Let's just close this up here. I'm a bit suspicious because that seemed fairly straightforward to me. Let me end the if there. So I need to output total number of windscreens tested. I'll put total tested, comma, sample. That's that one. Number of satisfactory windscreens, output, satisfactory screens. My writing's getting worse. And that will be satisfactory. Okay, let me just double check that because it seemed very straightforward. So, design an algorithm. Let's just double check. green. Okay. So input the required width. Yes, we've done that. Number of windscreens to be sampled. Yeah, we've done that. The width of each windscreen, which is here. So we've done those 3 inputs there. That's good. Output for the program should be for each windscreen found to be over width. So here's my check to check if it's over width. The windscreen number with the width of the windscreen number and width of the windscreen. Done that. All outputs should contain suitable messages. Well, they do. They've all got strings around them as well as the actual outputs. And then we've got over width windscreen. Yeah. And total number of windscreens tested. Yeah. And number of satisfactory windscreens. Yep, very good. We've closed our if statements. The only thing I've not done is I've not incremented my loop. So for should be here. Next I. Okay, that local variable needs to increment every time. And that's it for question 3. And that should get us all of 6 marks.